Hello, we have Hunter and Brandon and Zach. So here we are we looked at the rest of our worksheet, so I will show you the answers to that, and that will help you catch up with us. So I'll do that right now so I don't have to worry about it later. They are also written at the bottom for you, but this is the work that will help you catch up and understand how those answers were obtained. Does that show up?
Yeah, pretty good.
All right. Very good. Now we're moving on to a lab, and let's show them that. What do you say? Can they see the whole thing?
Yep.
Okay. All right, we just are reading this part together, so you can read along with us. So, Emily, would you read number 1?
Find the weight of your friction block using your force.
All right, we don't have a force scale. We have a mass scale. Does anyone know of any regular scale in the school that would measure something? Okay, so what we have to do then is get the mass and convert it to weight. Weight equals mg, so we can handle that. So, all right, go on number 2, Alex.
Record the weight of friction block in the data table.
All right, let me show you what we're weighing. Here's the friction block. Not very heavy, but it will have some mass, it will have some weight. So this is what you're going to weigh, or find the mass on here and change it to weight and record it. So you see where you record it? Under block weight, okay, the first column. So notice they're using newtons there. All right, Emily?
Attach the force scale to the friction block and pull the scale horizontally with the board at a steady rate, and record the average force reading in your data table under the column friction force.
Okay, so the whole point of this is to slide this block on a board. We'll take our boards out from the corner. We're going to take our, it's going to be a horizontal board, and it's going to be sliding along it, sort of like the cheesecake, the pumpkin cheesecake, sort of the same thing. So we're going to be taking the force on number 3. She talked about attaching a force scale. So this is our force scale. So you'll be attaching it, dragging it along the wood. All right. Brian, did you read number 4?
Sure. At CMAS, calculate the additional weight using g equals 9.8 meters per second squared for each of the drop shafts, and record your findings in the data table. This total amount of weight will be known as the moment of force. Pull the block as before to find the moment of friction force of this total weight.
All right, so you're going to pick a mass, any mass, and this has written on it somewhere. Some of them are hard to read. This says 200 grams. We'll switch that to kilograms, and you can add that to your block. Then you'll repeat similar calculations with extra mass. And it says continue until data table 1 is completed with 5 total trials. So we can add different masses for each one. So Emily, would you read number 6?
Calculate the friction coefficient by dividing the friction force by the normal force. This coefficient has no unit since you are dividing units by units.
All right. So does that surprise you that that's the final calculation? But we know the force of friction is right here. So we're going to find this in lab, we're going to find this in lab, and we're going to divide force normal on both sides, and we will calculate use of K that way. So that's the goal, is to find the coefficient of kinetic friction for wood block on wood board. So, and back to you, Emily, number 7. Where are we? 7.
Find the average value of your friction coefficients and record beneath your data table.
Right. It doesn't matter what the weight is, the mass on your board. We should have the same coefficient of friction. So you'll notice you'll have about the same one in each column, over the last column, and you'll be averaging them. So Alex, the last one.
Make a graph of friction force versus normal force. Include the origin as one of the data points. Determine the best fit equation of your line and report on the graph. Notice how close the slope is to your average friction coefficient.
Okay. So that'll be the final one. And we'll see how long that takes us as to whether we'll go on. On the back, they ask you to do the same thing, but they want you to use the skinny side of the block. And part 3, they want you to put a shoe on the board and see what the coefficient is for a shoe. And it keeps going on and on. I've never gotten very far. It'd take about 3 weeks, so at least the first part we're gonna do. Maybe a second. Alrighty, so way we're seated is good. How about you 3 work together and you 2 work together and start getting, so I only have one scale here, so let me get you some.
Do we use the same break weight for all of them, right? We can just.
Yes. Yes, you don't have to keep weighing it. Right.
Should I stop the video?
Here's your block, and here's your scale, and let me know if you need anything else.
Trying to weigh it.
I'm gonna clean that off.
Where's Kyle?
Yes.
Throw back to chemistry class.
All right.
Wait.
Let me show them. Have they seen the equipment? I guess a little bit.
Yeah, they seem.
Okay. All right, we're going to work on this together in our group, so you can join us when you come in. Hope that's soon.
Yeah,
Bye.
come to school, thanks.